We're doing pretty well so far with learning about JavaScript numbers. Now, the next stage that we want to cover in a bit more detail, now that we've discussed integers and floating points, we want to examine how we can parse numbers or non-number primitives into numbers. Now, for this, JavaScript gives us two things. It gives us something called a parse int, which parses a value into an integer, and it also gives us parse float, which parses into a floating point number. So let's go ahead and dive in. What we want to look at first is something like a string value of 55 pixels. Now, if we want to convert this over to a real number, we can use the parse int. This then we can save and log this out on the console. Now, there's actually something quite interesting with the parse int function. If we hover over this definition of the function, we can see that we have this radix parameter, which is optional, which is denoted by the question mark, and it's expecting a type of number. Now, if we have a look a little closer, a value between 2 and 36, which specifies the base of the number in the number string. If this argument is not supplied, strings with a prefix of 0x are considered hexadecimal. All other strings are considered decimal. Now, I don't know about you, but that sounds quite confusing. Now, the golden rule, and the only rule that you need to know, is that you pass the number 10. This means that the number is parsed with a base 10 and returns the integer that we're expecting. Now, this is important because it guarantees the accuracy from the input variable. Now, this again goes way down into how binary actually works. We could, in fact, do something and pass in perhaps the number 2. Now, you can see this gives us not a number. If we type 0110 and hit save, we get the number 6. So this is actually changing between binary, decimal, octal, and the different types of number formats. Now, if you're unsure, it's probably best just to use a base 10. If you need something more complex, then I would have a further read about these. So let's go back to where we were, which was parsing the integer of 55. Now, we do also have the ability to pass a decimal. So what we'll do is duplicate this, and what we'll do is 55 point, and we'll just add a load of 9s. Now, you can see that we've taken no decimal places here. We're still using parse int. So it's taking the actual whole integer and not the floating point. So what we want is actually the float. Now, parse float does not take the radix parameter of 10, so we can hover over this and you can just confirm that it doesn't expect it in the function definition. But over in the console, you can see that we have successfully got our 5 with 4 9s, and this is a real floating point number. This is a proper number with a decimal 0.999. And we can go ahead and confirm this. We could multiply it by 10, and you see one of those 9s shifts up a place. So the rule here is use parse int if you want to parse a whole number, which we know is an integer in JavaScript. There aren't different types of numbers in JavaScript. There is just one number, but they all exist under the same object. And both of these are used in a case such as this, where we have a string and we want to get the number from it. And I think pixels are a really good use case for us here. Now, if we continue in our learning, let's go ahead and add another console log. Here we're going to add a number, and inside it, we're going to add 55, E, and then 10. So we'll save this out, and you can see that we now have 55 with a bunch of zeros. Now, we haven't covered this E, but it's in fact a floating point number representation. These aren't typically things that we would declare ourselves, but we might get them back as a value when we're dealing with huge numbers in JavaScript. And this E actually stands for exponent. Now, if we take a closer look, you see we have the number 10 here. Let's go and count these zeros. So we have 3, 6, 9, and 10. So the E is in fact adding 10 zeros. Now, this again is just to show you how we can convert particular number strings into real number literals or objects in JavaScript. Now, as we've already looked at this number function in previous videos, it shouldn't be a surprise that something like this gives us not a number, because we've learned that if we pass in things that are not valid, such as px, we then see this not a number. Now, The number function is quite interesting because by default it's doing something very similar to our parse float up here. You can see by default we're getting that 9999, whereas parse integer, it wouldn't in fact do this for us. You can see that everything is ignored up here. Now there's one more interesting piece of how we can use a JavaScript operator to convert a string to a number. So let's go ahead with 99.5555, and what we're going to do is simply put a plus in front of it. Now you can see that that has now pretty much done the exact same thing as this number function above. So this in fact converts the string to a number. Now I don't know about you, it's a great way to obviously do it. It's shorter than number, but it looks like we are potentially adding something together. We might have the number 9 and we might be doing plus and then have this plus again. And you can see that this starts to look slightly confusing. This is part of one expression here, and we're simply adding 9 to the result of that. So in this lesson, we have successfully learned about the two different types of numbers. We've covered parsing integers, we've covered parsing floats, and then we've looked at some of the quirks of the language using this plus operator, and we've also explored the number function and this exponent, which is in fact a scientific notation for declaring numbers that are too big or too small to be conveniently written in a decimal format, because it can simplify certain operations that we want to achieve. Now, there's one thing that we haven't looked at in a bit more detail, and that's something if we add a px to this, we get this not a number. So let's dive into the next video and we'll investigate not a number, how we can detect it, and so forth.